This is lesson 12.2, relate points in the coordinate plane. It is found on pages 557 through 560 in your workbooks. So does anyone know what a vampire's favorite fruit is? Yeah, what is a vampire's favorite fruit? I bet some of y'all are thinking blood orange, but nope. It's a nectarine. Nectarine. Although I think blood orange could come close in second place. Moving along. So our learning target in this lesson will be to relate points and find distances in the coordinate plane, and hopefully, as always, you can do it on your own at the end of the lesson. Our look back wants us to plot and label each ordered pair in the coordinate plane. Alright, so let's go ahead and do that. Alright, so we've got A at 4, 2, B at 10, 2, C at 1, 1, and D at 1, 9. And then it wants us to draw a line through each pair of points, so the horizontal line A and B, and the vertical line C and D. So here's what that would look like. So in our look ahead, it says plot two other points on the horizontal line. What do you notice about the ordered pairs of the points on the line? Well, let's do that. So we've got, let's put one here and one here. What do you notice about the points on those lines? Yeah, they have the same y coordinate, don't they? So let's put that down. The points have the same y coordinate. And then the next question asks, plot two other points in the vertical line. What do you notice about the ordered pairs of the points on the line? Well, let's do that. So let's have a point there and a point here. What do you notice about those? Yeah, they have the same x coordinate. So let's write that down. The points have the same x coordinate. Well, let's look at our key concept to relate points in a coordinate plane. In a coordinate plane, the horizontal number line is the x-axis. So horizontal number line, x-axis. The vertical number line is the y-axis. So the y-axis is the vertical number line. For an ordered pair, xy, the first number is the x-coordinate. The second number is the y-coordinate. You can count units or use subtraction to find the distance between 2 points when they lie on the same horizontal line or vertical line. So in our examples here, what do you notice about the x-coordinates of the points on a vertical line? The points on a vertical line have the same x-coordinate. And then in our next example here, find the distance between C and D. Think. The points lie on a horizontal line. So C, 1, 3, 1 unit right of the y-axis. So we got it right here at 1. D, 4, 3 is 4 units right of the y-axis. See? 4. So you've got 1, 1, and 4. So the distance between the points C and D is 4 minus 1. 4 minus 1, so that's 3 units. And our I can statement there says, I can explain the relationship between 2 points that have the same x coordinates or y coordinates. Alright, so let's do some in-class practice. Number 1 says, what do you notice about the y coordinates of the points on the horizontal line? And here's what we're going to say. They are all the same. So all the y coordinates on that one are going to be 3. Alright, so if I go to number 2, it says find the distance between points E and F. Well, E is at 5, F is at 1, and so we just do 5 minus 1. That's 4. Now look, I know that 5 minus 1 is really easy. I know you can do it in your head without needing to write it down. I still want you to write it down. Why? Because I want to see where you get this number so that if it's a different number, I can see, oh, you were putting down the wrong numbers. Alright? So number 3 shows us that we don't even need to have the coordinate plane in order to see the difference, because it says find the difference between the points. Well, look, if they're both 5, we know that it's gonna be on the y coordinate, right? So we just do the x's, and 4 minus 2, we've got 2 units. Try out number 4 real quick and we'll go over it. Alright, so we get 4 and 4, so we know it's going to be on the x coordinate there. So the difference in the y coordinates, 3 minus 0 is 3. Going on to number 5, it says what is the y coordinate of the points that lie on the horizontal line segment? So this line segment. Go ahead and write that down real quick. Yeah, it's 7. And then number 6 says, what is the x-coordinate of the points that lie on the vertical line segment? So these coordinates, what would those be? That's right, it would be 5. And our I can statement is, I can count grid lines to find the distance between 2 points. Alright, I want you to go ahead, read and solve number 7. Read and solve number 7 and then we'll go over it. Alright, which line segment is longer? We know it's the red. So, the red, and then how much longer? Well, 7 minus 1 is 6. 5 minus 1, not 4, minus 1 is 4. And if we do 6 minus 4, that's going to be 2 units longer. So 8 and 9 are open-ended. They want us to name 2 other points that lie on the line that passes through the given point. So I'm going to work out number 8 with you, and then number 9 I want to be a Jolly Rancher moment. Alright, so name 2 other points that lie on the line that passes through the given point. So 0, 6, we get 0, 6, and then 5, 6. So it's this line here. Well, I know that my y coordinates are going to be 6. See, that's my y coordinate. It's going to be 6. And it wants between this one and this one. So I can do 1 and 2. Right? Because 1, 6 lies there. 2, 6 lies right there. Alright? I want you to go ahead and solve number 9. Plot that line. Use the one that's on number 5 and 6 as your coordinate plane. Plot the line and then put your ordered pairs there, right? And then I'll go around and check on it and we'll go over it. Alright, so 4, 2, 4, 2, and 4, 8, 4, 8. So between these two, so obviously our x-axis on both of them has to be 4. So that's the first thing we need to do. The x-axis both have to be 4 because it's along this line and it's on the x-axis is 4. Well, in anything between 3 and 7, so I'm going to say 3 and 4. You could do 4 and 5, you could do 5 and 6, you could do 6 and 7. Right? As long as the x-axis was 4. So on number 10, it's matching. It says match each pair of points with the distance between the points. I have put on my screen the coordinate plane from our look back. So on my first one, I'm going to plot the coordinates. So I've got 2, 3, 2, 3, and 2, 6. Well, I can do 6 minus 3. That's going to be 3 units. Now, I don't necessarily even have to plot them. What I can do, here's 5, here's 4. Now, 0 is the same, so I don't do anything with that. So 5 minus 4, that's 1 unit. I've got 5 the same there in the y-coordinate, where the x-coordinates are different. So 5 minus 1 is 4. And then 7 is the same in the x. The y-coordinates are different. 5 minus 3 is 2. So 11 and 12 talk about parallel lines. Number 11 says, which points do not lie on a line that is parallel to the x-axis? Well, let's look at this. And again, I've got my coordinate plane from my look back. So 3, 1, and 7, 1. So 3, 1, and 7, 1. Is that a parallel line to the x-axis? Yeah. Yeah, it's a straight line and they never touch. Well, 8, 4, and 2, 4. So let's do those. 8, 4, and 2, 4. So 8, 4, and 2, 4. Those are parallel. All right, and then we've got 1, 2, and 1, 6. So 1, 2, and 1, 6. Up. That's perpendicular to the x-axis, isn't it? So I want you to notice something. I'm going to do this fourth one here. 0, 5. So 0, 5, and 6, 5. 6 and 5. That runs parallel. I want you to see something. See the y-coordinates? When both y-coordinates are the same, we know it's going to be parallel. When both x-coordinates are the same, we know it's going to be perpendicular to the x-axis. Well, let's take a look at number 12 here. Let me erase this, not put another line. It wants to know which points do not lie on a line that is parallel to the y-axis. So let's start doing them. So there are 3, 1, and 3, 3. So 3, 1, and 3, 3. That's parallel to the y. 2, 1, and 3, 1. So 2, 1, and 3, 1. Oh, check that out. That's perpendicular. All right, I want to do these next two. 7, 0, and 7, 6. That's parallel to the y-axis. Then 5, 5, and 5, 4. So 5, 5, and then 5, 4. It's a small line, but it's still parallel to the y-axis. So you notice that when the x-coordinates are the same, you have a line that's parallel to the y-axis. When the y-coordinates are the same, that line is going to be perpendicular to the y-axis. Well, let's connect this to real life. In our example, you are working at an archaeological dig. You want to rope off a rectangular section of the dig. How many meters of rope do you need? The rectangle has a length of 8 meters and a width of 7 meters, so find the perimeter P. So P equals 2 times 8 plus 2 times 7, right? Because if we're looking at this, we've got 9 minus 1. That means this side is going to be 8. That means this side is going to be 8. We got 8 minus 1. That's 7. Both sides are going to be 7. So 2 times 8 plus 2 times 7. 16 plus 14 equals 30, so you need 30 meters of rope, right? So we have to take those things that we already know. We know the length of that and the length of this, and we know how to find perimeter. Alright, so number 13 is kind of the same. You want to use fencing to make a rectangular dog pen. How many yards of fencing do you need? Alright, go ahead and figure that out and then we'll go over it. Alright, so we've got 4 minus 1, that's going to be 3, or you can just look at that and have 3. So we have 3 plus 3, or 3 times 2. And then we have 8 minus 0. 8 minus 0, that's going to be 8. Well, we can do 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be 8 plus 8. So 6 and 16. 16 plus 6 equals 22. So 22 yards. I would like for number 14 to be another Jolly Rancher moment. Alright, so go ahead, read and solve it. You have to get both of them correct and show your work. Alright, go ahead and do that and then we'll go over it. You ran 5 laps around the edges of the volleyball court. How far did you run in feet and in yards? Alright, so 5 laps around, and you went around the volleyball court, right? Each unit represents 6 feet. Oh, did you get that? So we get 6 minus 1. We got 5. So this side's going to be 5. Or 30. So this side is 30. This side is 30. And then we get 11 minus 1. We get 10. So that's going to be 10 times 6. That's going to be 60. So 60. Right? So 60 plus 60 is 120. 30 plus 30 is 60. So that's going to be 180. And I did it 5 times. 18 times 5 is 90 with 1 0. 900 feet. Yeah, did you work all that out? Did you make sure and multiply it by 6 as well? And then yards, 9 divided by 3 is 3 with 2 zeros because I divide that by 3 because there are 3 feet in each yard. Well, hopefully a lot of you got that right. You were paying attention to the information it gave you and were careful to do all the work. Alright, number 15 is open-ended, but I'm going to give you some parameters for it. It says draw a rectangular flower garden that has a perimeter of 28 feet. So I'm going to give you this side here. Right? I want you to draw a rectangular flower garden that has a perimeter of 28 feet. And this one is also a Jolly Rancher moment. I want to see if you can get this. Alright, go ahead and do that and then we'll go over it. Alright, so this is 4 feet, isn't it? Well, I need this side then to be 10 feet. And this side to be 4 feet. Yep, that would be 28 feet. Well, alright, let's go back to our learning target. Relate points and find distances in a coordinate plane. Hopefully you can do that on your own. Hopefully you can explain the relationship between 2 points that have the same x coordinates or y coordinates. You can count grid lines to find the distance between 2 points, and you can use subtraction to find the distance between 2 points. And as always, peeps, you know I love you. I'll be glad to help you. All you need to do is ask. And you peeps who are at a number 4, you can help your peeps who are at a number 2. Well, alright. Y'all have a good day.